Okay, so the last time I've showed you how to create the gauge using the 16:2 character display and the Arduino UNO. Today I will show you how to make it smooth. And the biggest challenge will be the number of custom characters, because we can only have up to 8 of those. So let's get started. So I have divided this gauge into 3 different sections, so the start section, the middle section and the end section. And as you can see down below, each section can have multiple different states, from the empty one to the fully filled one. And if we count those individual states, we end up with the number 16, which is obviously much more than we have available because we can only have 8 different characters. The good news is we can use the ASCII character 255, which is fully filled character, but we are still left with 15 different custom characters that we need. Thankfully, we can not only create custom character inside the setup function, but we can also do it inside the loop function, so we will end up with dynamic characters, and that's exactly what we will do. So we will have 1 dynamic character for the starting piece, 1 dynamic character for the ending piece, and then 5 different characters for in-between pieces. That will leave us with 7 custom characters, which means that we still have 1 available for something else. Now you might be thinking why we don't use a dynamic character for the states 1 through 4, and the answer is it's not so easy. I will tell it to you in a minute. Before we start writing the code, let me tell you about the sponsor of this video, which is PCBWay, and as the name suggests, is a service for creating your own PCBs, which is something that I would like to try soon. In the meantime, if you click the link in the description of this video, you will get a $5 coupon, which is exactly the amount that's needed to get 5 boards manufactured, so we'll only pay for shipping. Finally, let me tell you that you can change the color of the display if you go to the JSON file and set the background and color for the 16:2 display. So let's get back to our gauge. Same as the last time, we will be using Walkway, which is a free online Arduino emulator that you can run in your browser. This is the project from the last tutorial. You can see that we are using the Liquid Crystal I2C library because we are using the I2C version of the display, which is quite convenient because we only need the data and the clock for the data cables, and then of course the VCC, which is 5 volts, and the ground. So in total we only need 4 different cables to connect this display to Arduino. You can see we have some helper arrays to define the look of the individual custom characters. Then in the setup we create those custom characters, and obviously we draw those inside the loop function. So we will be using this project as a starting point. You can find the link in the description. We will start by deleting or commenting out most of the code, because what we want to do right now is to create a special character not inside the setup function, but inside the loop function. So I will delete everything that's related to the GPU gauge, which is this piece, and also there is some GPU gauge variable in here which I don't need anymore. I don't need to create a character right now in the setup function because, again, it will be done inside the loop function, so I'll comment it out. And as for the drawing, I don't need to draw it. I only need to keep maybe this piece because it will be needed in the future, but I'll comment it out, and that's probably it. So what I will do is I will create a new array that I will call gauge left dynamic. Unlike the other arrays, I will not initialize it because I will create it on the fly. Now, because this is the array, I need the loop function, so for loop function inside the loop function. So I'll say for y equals 0, while the y is smaller than 8, I will just increase it by 1. And here I want to set the gauge left dynamic to some value. So the index will be y. And let's start by setting it to gauge fill, but I will rename this gauge fill to be gauge fill underscore 5, which is an indicator for me that all 5 columns are being filled. So I will just say that the gauge left dynamic equals gauge fill 5, and of course this should be y as well. When I have the array initialized or set, I will create a new character. So I'll say lcd create character, and I was using index of 5 for my custom character for the gauge left dynamic. So all that's left to do is to actually print this. So I'll say lcd write character number 5. And if I rerun the simulation, I should see a fully filled rectangle. Not that much exciting, but the exciting part is now we can change it on the fly. And there are multiple ways how to assign a different content for this gauge left dynamic array. And one way might be you will define more arrays. So you will define gauge fill 4 for only 4 columns filled, and gauge fill 3, 2, and 1. And then you will add a lot of if statements in here and assign a different fill number to the gauge left dynamic. There is another way, and this one is that you can imagine that this is the display content and this is our 1x1 array. And by default we assign it like this, so every pixel will be filled. But what we can do is we can shift everything to the left side, and in this case, if we shift it by 1, this left side will not be even visible, so there will be an empty column on the right side. If we shift it by 3, we will show 2 columns being filled and 3 not being filled. And there is actually a function for this, which is called the Bitwise Operators, in this case the bit shift left. And there is this nice looking GIF file that shows this in motion. So the shift left is what we are looking for. We add a new 0 on the right side and shift all the bits to the left side. We will lose the very left bit of the content, but that's perfectly fine in our case. So let's try to do that. The only thing that we need to remember are those two characters that we will use in our code. So I'll switch to our code and we will bit shift the content of the gauge fill 5 by some amount, and the amount will be defined by an error variable. So I'll create a new variable, integer variable called move offset, and set it to 0 for example, and then I will increase it by 1. So I'll say move offset equals, actually not equals but plus plus, increased by 1, and if the move offset is bigger than 5, I will just set it back to 0. And of course use the move offset inside the calculations, and I will most likely increase the delay to maybe 200 milliseconds. So if I rerun the simulation, character is changing, it's going from fully filled to empty character. So that's exactly what we are looking for. There is still one piece of the puzzle that we need to solve, and that is, if you look closely at this image, you will notice that the filling piece is actually being combined with another empty piece. So let's try to do that, and for this we will also use the bitwise operator, and in this case we will use the OR operator. So we are combining two numbers together, but where there is a 1 in one or the other number, it will always result in 1. So it's only when both numbers are zeros, it will result in a 0. In our case, it might look like this. So we have the filling piece and we have the empty piece, and if we combine those together, whether there is a 1 in filling piece or the empty piece, it will result in 1, and only when they are both zeros, it will result in 0. So let's try to do this, and the symbol for the OR function is the pipe function. So for this one I will jump into our code, and I will actually rename this gauge center to gauge empty because it makes more sense in here, and I will get rid of the left and right arrays because we don't need those anymore, and I will try to combine this gauge empty with what we already have. So I'll maybe put it inside a bracket just to make sure, and I will insert pipe and this gauge empty. This is also an array, so I'll create an index y, and if I rerun this simulation, I should see the filling piece being combined with the empty piece. Let's create all the arrays we need, and for this I will use the custom glyph generator, and let's review our image to see what we already have. So we have this piece, which is the gauge empty, and we have this piece, which is the gauge fill 5, and I will show you the names. So we also need to create the fill 1, 2, 3 and 4. We need the gauge left and gauge right, and for now let's ignore those rounded corners, those missing pixels in the corners. We will add those in the future, and we of course need the gauge left dynamic and gauge right dynamic, but those two will be empty without any content. So let's just recreate those missing arrays. So this is the gauge empty, which we already have. So we have the gauge fill 1, gauge fill 2, gauge fill 3, gauge fill 4 and the gauge fill 5, which again we already have, and then we need the gauge left and the gauge right. Let's just copy this into our code and name this properly. So I will copy this piece of code and just copy it in my code inside defining the arrays. And again, the first one is gauge empty, we already have this one, so I'll just replace it with the same name, but the content should be the same as well. Then there is gauge fill from 1 to 5, so gauge fill 1, 2, 3, 4 and 5. And finally there is this gauge left and gauge right, which are only helper arrays. We will not actually display those, but we will use those in our calculations. We already have the gauge left dynamic, but we also need gauge right dynamic. And of course this is the redefinition, so that we can remove the original definition. Again, those should be the same values. Looking at the drawing again, we know we can define some of those characters that will not be changing. So gauge fill 1, 2, 3 and 4 and empty will not be changing, so we can define those in the setup. So I'll just get rid of most of the stuff and only keep one of the LCD create character. And I will start maybe with the number 7, which will be the gauge empty. Then the character with number 1 will be gauge fill 1. Then gauge fill number 2, 3 and 4 will correspond to the special character number 1, 2, 3 and 4. And those are pretty much all the characters that we can define in the setup function, because only those 5 will not be changing. Then we have 2 more, gauge fill dynamic left and right, which will be changing, so those will be defined inside the loop function. We are still not drawing anything super exciting on the screen, so let's just change it. And I just noticed that this move offset is in between the setup and loop, so I will move it to the top just so all my variables are on the same place. And I will create a new variable that will be an array of characters, so I'll say char gauge string, and I want to have it certain size, which I want to define as well. So I'll create a new integer gauge size characters that I will set to maybe 10 for now, and since I want to use this as the size of this array, I need to make this a constant, so I will say constant integer gauge size characters, and I will use this value for the size of the array. But since we need one closing character that will be a null character that will set the size of this string, I need to say +1. So again, the gauge string will hold all the individual characters of our gauge, and then we will just simply print the gauge string value. Let's populate the gauge string with some actual characters. So for this I will create a new loop inside the loop function, so I'll maybe copy it from somewhere else. I should have a loop in here, so I'll copy this piece And after creating a custom character, I will say for y equals 0, while y is smaller than gauge size characters, I will just increase it by 1. And what I want to do is I want to differentiate between a few different scenarios. So as we've shown previously, if the y equals 0, which means the character is the first character, we always want to print the gauge left dynamic, which we already defined as the custom character number 5. So in this case, I will set the gauge string of index y to be byte 5. If the y equals the last character, so in this case it will be gauge size characters -1, we want to always draw the gauge right dynamic. And we haven't even created the special character, so I'll just copy this one and create a new gauge right dynamic character that will be placed on the position number 6, just because I've defined it in my drawing. So in this case, if this is the last character, I will set the gauge string to be byte number 6, which is the last character. And in all other cases, this will be some in-between character. So for now, we can say to anything. So for example, the empty character, which is number 7. I will make sure that the semicolons are here. And after all of that, instead of LCD write 5, I will change this to LCD print, and I will print the content of the gauge string. So let's rerun the simulation and see what we got. So you can see that the left piece is still changing because this code is still here. Then we have the in-between characters, but we don't see anything for the last one because we have created it with the create character number 6, but the gauge right dynamic is actually not set in the first place. So what I will do is I will quickly copy this piece of code, which is for saying the left piece of the gauge, and I will change it to gauge right dynamic. I will keep it as it is, with the exception of I don't want to merge it with gauge empty, but I want to merge this one with the gauge left, and the second one I want to merge with the gauge right. So again, if I rerun the simulation, I should see something that resembles the left part of the gauge and the right part of the gauge. And you can see that both of those are changing at the same time. So let's quickly fix it. And just to make sure that we are on the same page, I will add a few more comments into my code. So what we want to do now is to count how many pixels the filled gauge should take, and of course that will be based on the CPU gauge value. And there are two different ways how to count the pixels. If I zoom in, you can see that each character is made from 5 pixels for the width, but there's actually a gap in between those characters, which is actually 1 pixel in the size. So we can either count with this gap as counting as 1 pixel, or we can just ignore it. And that's what I will do now. I will only say that each character is 5 pixels. I will not care about the gaps. To calculate the pixel size, I will create a new helper value, which I will call units per pixel. And this will be calculated by multiplying the number of characters, which is stored inside the constant gauge size characters, multiplied by 5 because each character has 5 pixels. And I want to divide it by the number of values, and I'm going from 0 to 100%, so I'll divide it by 100%, so 100. Then I want to calculate how wide the gauge should be, so how many pixels it should take. So I'll create a new integer values because pixels are of course integers, and I will call this value in pixels. And I will of course use the CPU gauge that I will multiply by the units per pixel. Now of course, since this is the integer value, I need to convert it to integer, so I'll maybe round it. So I'll round this calculation. Just to make sure that everything works as expected, I might print those. So after displaying the gauge, I will move the cursor to the next line. So I'll say LCD set cursor to 0x and 1 for the Y position. Then I will print the value of the CPU gauge. Next, I might print the percentage sign just so that I know this is the percentage. I will set that this equals to the value in pixels. So again, I will print the value in pixels. So I'll copy it in here. And one more thing is I will print the number, actually the string px, so I know that those are pixels, and with few empty characters. So if I restart the simulation, the gauge still looks wrong, but now I see the value of the CPU gauge in percentage and how it corresponds to the size in pixels. And just because currently the gauge is taking 10 different characters times 5, it means I have 50 pixels. So for 100%, I don't know if you've seen it, for 100% it should show 50 pixels. Like so you can see all our calculations are working as expected. Now that we know the value in pixels, we can find out which of the characters should be the one that is changing, so where the tip of the gauge should be displayed. So I'll create a new helper variable called tip position, and for now set to 0. And let's say that if the value in pixels is more than 5, which is the size of the first character, we will set the tip position to be 1. if the value in pixels is bigger than the maximum value, which is gauge size characters times 5 minus 5, then the tip is inside the last character. So we'll set the tip position to be 3. And in all other cases, the tip will be somewhere in the middle. So we'll set the tip position equals 2. Let's partially fix the appearance of the leftmost and rightmost part of the gauge. And this is this code, so dynamically creating the left part of the gauge and the right part of the gauge. And since now we have the tip position value, we can say that if the tip position equals 1, that means that the tip is inside the first character, so we should dynamically create this character like so. So I'll just put it inside here. But in all other cases, it means that the tip position is either inside the middle of the gauge or at the end of the gauge. So for the first character, we can use the fully filled character. So I will say that if the tip position is somewhere in the different position, the gauge left dynamic actually equals to gauge fill 5, like so. We will do something similar for the right part of the gauge. So again, I can say that if the tip position equals 3, which in here means tip of inside the last character, then again we will do the dynamic part of the gauge, something like this, even when the move offset is not yet set properly. In all the other cases, it means that the tip position is either inside the middle or over the first character, which means that the last character should be empty. So in this case, I will say that the gauge right dynamic is the empty gauge, which means the gauge right, that's the empty version of the rightmost character. And I just noticed that it should be of course 3, so if the tip position equals 3. So if I rerun the simulation, it still doesn't look super right, but you can see that something is changing when it's below 10%, then it stays on the filled side, and when it will be approaching 90%, it will also be changing, so the last character is again changing. Again, it's not super right because the move offset has to be adjusted, but it's doing something. Let's talk about the move offset variable, which right now it's being set kind of randomly. It just increases inside the loop from 0 to 5, but we obviously want to set it properly, and we want to set it based on the value in pixels. So I've created this Excel spreadsheet where I have all the values in pixels going from 0 all the way to 50, and I want to somehow set the move offset. So for example, for this picture, the value in pixels is 8. So I want to, for this particular character, I want to offset it by 2. So for 8, I want to offset it by 2. Imagine if the value would be 7, I would want to offset it by 3. If it would be 6, I want to offset it by 4. And if it would be 5, I will jump to the next character, so it will be 0. And I can continue like this. So for 4, it will be 1. For 3 it will be 2, for 2 it will be 4, and for 1 it will be 4. So I want to somehow find the equation to, based on these values, give me those values. And since I see that those values are repeating, I can use the modulo function, which is signalized by the percentage character in the C code, but inside the Excel there is actually the modulo function. So modulo of this value, then the divisor will be 5. So if I do it like so, I can see that those numbers are not matching. So this one is going from 4 down to 1. This is from 1 up to 4. So what I want to do is I want to set it to 4 minus the modulo, and I'm selecting all the cells. When I hit the Control Enter, it will update all the cells at once. So the only missing piece is this is going from 4 to 1, and this is from 3 to 0. So again, I want to change the value in pixels to be value in pixels minus 1. Press the Control Enter key, and I can see that now those numbers are matching. So the final equation will be something like 4 minus modulo of the value in pixels minus 1, and I will modulate it by 5. Let's try to write it one more time in here. So it will be 4 minus, and I will use the value in pixels minus 1 modulo 5, and most likely I will just put this inside the brackets just to make sure that the calculation is in the right order, like so. And hopefully we can use this equation right away. So I'll copy it into clipboard, jump into my code, and instead of setting the move offset to be plus plus, I will just set it move offset equals the 4 minus value in pixels minus 1 modulo 5 semicolon, and get rid of this one. And there is one more thing to fix because it's not value in pixel but value in pixels. So let's rerun the simulation, and now I should see the correct version of the first cell. You can see when it goes from 0 to 10%, it's filling the first piece of the gauge, and when it goes from 90 to 100%, it will be properly filling the last piece of the gauge, as you can see right here. So we have the first and last piece of the gauge covered. We just need to cover the middle part of the gauge. And we are actually very close to finishing the gauge, even when it looks like that might not be the case because the whole middle part is not doing anything. But that's this part. So we are setting all the characters. we are properly setting the first character and the last character, but for the middle character there are 3 different options. It could be the empty, the tip or the fill, and we are always setting it to empty for now. So let's just fix this. I will comment this out and I want to create a new if statement. So I will say that if the value in pixels is smaller or equal to the current pixel being drawn for the character, which is the I times 5, because there are 5 pixels for each character, it means that we want to draw an empty character. So I'll copy this one, gauge string y equals byte 7. The other option is if the value in pixels is bigger than I times 5, which is bigger than the current character, but at the same time smaller than the next character, which is I plus 1 times 5. In that case, we want to draw the tip of the character. So we want to draw one of those gauge fills, so either gauge fill 1, 2, 3 or 4, which corresponds to the special character number 1, 2, 3 and 4. And I believe that we can somehow reuse a move offset, but the move offset goes from 4 down to 0, which means that, for the character number 1, we want to offset by 4, for character number 2, we want to offset by 3, and so on. So we have to adjust it a little bit. So I will say that the gauge string equals byte, but for the byte it will be the 5 minus move offset. And finally, if this is not an empty character or if this is not a tip, it must be the filled character. So I will say else the gauge string will be byte number 255, which is a built-in character for fully filled character. And hopefully when I rerun the simulation, now the whole gauge should be filling, so it's perfectly filling for every single character, just like you can see right now. If I compare the gauge with my previous creation, you can see that the first and the last piece actually has like the rounded corners, so let's actually do that as well. We will also use the bitwise operators, but this time we will use the AND operator, and it works in a way that both numbers need to have the number 1 in there in order to end up as 1. All the other cases it will end up as 0. So what we can do is we can create a custom mask for both the left and right piece of the gauge. So let me create the mask for the left gauge, for the first character of the gauge, and one more for the last character of the gauge. So if we apply the AND bitwise operator, the final pixels will be only visible on those black areas. On this white area, it will never end up as 1. So let me copy those 2 arrays into my code and name those properly. So I will name it gauge mask left for the first one and gauge mask right for the second one. And then of course inside drawing a custom left and right piece of the gauge, which is this one, dynamic right left part of the gauge. As a last step, I want to actually combine the left gauge dynamic or gauge left dynamic equals gauge left dynamic and the mask, so gauge mask left. And I'll do the same thing for the right part of the gauge. So again, once everything is done, I will say that the gauge right dynamic equals gauge right dynamic and the gauge mask right. And obviously both the gauge mask left and the gauge mask right are arrays, so I need to set the right index. So if I rerun the simulation, I should now see the rounded corners for the first and last piece of the gauge. As a final steps, I can make the gauge a little bit bigger, so I can change the constant from 10 to maybe 16, which is the maximum amount of characters on this particular display. And it will look like this. Then I can also move the gauge to the second line, so when the gauge is being drawn, before I will just set the cursor to be 0, 1. Like so, and instead of printing all those temporary values, I will delete those and print back the buffer, which will include the CPU and the value, like so, and rerun the simulation of course. And that's it for the gauge, although I still have one thing to tell you about this 8th special character, which is this warning icon that I've used in my original design. And if you look closely, that's this byte array which is called warning icon, which has the individual pixels. And then inside the setup function, I'm creating a new character on the position of 0 using this warning icon. And in our code, we are actually not using character on the position 0. We are using 1, 2, 3, 4, 5, 6 down here and 7 up here. So we are not using position 0, number 0. And there is a good reason for that. So if you look at the ASCII table, the position number 0 is the null character, which is at the same time used to define the length of the string if we define the string like this, as the array of characters. So basically this is our string that holds the individual characters of the gauge, and it knows its length because when it encounters the character number 0, the null character, it just thinks it's the end of the string. And you can easily test it. Say if I scroll down a little bit before I actually draw the CPU gauge, I can try to set some of those characters. So gauge string, and let me just set I don't know, maybe character number 5. Let's just set it to byte 0 and watch what happens if I restart the simulation. You can see that now our gauge ends on character number 5 because it draws first 5 characters starting from 0, but then it encounters byte number 0 and it thinks that it's the end of the string. So it would be quite hard to work with the custom character on the position of 0 this way. It's still possible, but we have to do it in a different way. We have to use the LCD write function. And here we can say byte 0, but obviously we don't have this byte 0 defined. So I will just quickly copy it from my previous design. So I'll just copy this byte array of the warning icon and put it inside, maybe in here. And then from the setup of creating this custom character, I will also copy this line of creating custom character on the position 0. So if I do so and then restart the simulation, I should see the warning icon next to the value. So this is just something to be aware of. If you want to use a custom character on the position number 0, it might be harder if you try to use it together with the C style strings, which is the array of characters like this. Finally, let me show you how to run this on the real Arduino board. So I will copy everything into clipboard and start the Arduino IDE and just paste it in here. Now, if you don't have the used library, which is the Liquid Crystal I2C library installed, you have to install it first. So jump into the tools and select manage libraries. In here, type in the name of the library, Liquid Crystal I2C, and press the enter key. And somewhere there in the list, there should be the library that we are looking for, which is this one, Liquid Crystal I2C. You can see I already have this installed, but you need to install it if you don't have it. After that, make sure that the right board is selected. So select tools, board, and select the board. I'm using Arduino UNO, and make sure that the right port is selected. In my case, it's communication port number 7, and then just press the upload button, and hopefully you will see the message that says that everything was uploaded okay, and it will run on the Arduino. Now, if you want to know how to connect the display to the Arduino, I would suggest you watch my previous video where this is described into quite a lot of detail. And that's pretty much it for today's video. Thank you very much for watching. If you have any questions or comments, please put those down in the comment section for this video, and I hope to see you soon. Thank you for watching, and bye.